debris.
Gotta get this mod phys. Relativity? And E equals MC to the third? Wait, why am I doing this? I'm a second semester senior. Yeah, I don't really care about this. I'm gonna go watch some cartoons.
But wait, you can't do that. You know, even after colleges accept you, you can still get rejected if you don't do well second semester.
Are you serious? Are you saying that I'm in jeopardy of not going to U of I? One of the best schools in the whole world? I need your help, Duality Man.
Never fear, for help is here. My problem is I have no idea what you need help with.
Well, let's see, mod phys. Well, I understand that photoelectric thing, and I understand that triple slits. You know, that one thing. But the one thing I'm having problems with is that, DeBragly? What's his name? You know, the French guy?
So, you know the photoelectric effect says that light has to be a particle, right?
Yeah.
And the double slit, because of the interference pattern, light has to be a wave.
Okay.
So how can it be both? Well, scientists decided that what it has to be is that sometimes it acts like a particle and sometimes it acts like a wave, depending on the situation.
Oh yeah, I remember that. Dr. Dong told us something about that on the first day of class.
Right.
Right.
Well, what the scientist de Broglie, by the way, what he said is that not only is this true for light, but it's also true for all matter. Matter exhibits both the properties of a wave and a particle.
But wait, how does that make sense? I mean, my body doesn't have inference patterns like a wave.
Well, you know there's a certain cutoff where you can see when the wavelength is just too small to detect, right?
Mm-hmm.
So there's actually a formula that tells you how small your wavelength is.
Okay, well, do you remember what it is?
Right. So it's something with lambda, wavelength, and h. Hey, Denise, you remember what that formula is with de Broglie?
Of course, Bill, and if you were paying attention in class, you would have remembered that it's Planck's constant over the momentum equal to the wavelength.
But wait, my momentum is 0, and I'm not moving, so, well, that doesn't make any sense, so.
Yeah, but remember, you're not a single particle, you're trillions of particles, and their momentum is not 0.
Oh, okay. Well, how did de Broglie come up with this relationship?
So you start with this equation, right?
Oh yeah, I remember that.
All right, and you also know this one.
Yeah.
All right, well, you'll notice they're both in terms of energy, so you can set these two equal together.
I think I got the next step. Isn't it like h over p equals c over nu or nu? Right? Now the problem is I don't remember what to do after that.
Yes, you're on the right track there. And remember this other relation that we learned at the beginning of the unit.
Ah.
The wavelength is the velocity, which in this case we're using as the speed of light over the frequency. So this part you can substitute in for the wavelength. So you're left with Planck's constant over the momentum is equal to the wavelength.
I see.
Well, can you give me an example?
Okay, well think about it this way. Even if your momentum is only 1 kilogram meter per second, Planck's constant is so small that your wavelength is going to be minuscule. Remember, Planck's constant is equal to 6.63 times 10 to the negative 34 joule
That's a really small number.
seconds. It is.
It's really small.
I wonder how long that is. Wait, it's not a length. I can't do that.
But wait, isn't that only for light?
Well, remember, if you do the double slit experiment with particles instead of light, you get the exact same results, and that's the interference pattern. Based on this, de Broglie hypothesized that all particles have this wave-particle duality.
Oh, okay.
See, that's what this de Broglie stuff is. It's weird, but it makes a certain amount of sense. See all this math I did? Makes total sense.
Thanks, duality man.